Good morning. Today for class 10 in physics we'll discuss uniform circular motion. First of all, let us discuss that what is this uniform circular motion. As we know, when a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. Suppose there is a particle and the particle starts from moving from A and it constantly with a constant speed starts moving in the circular path. So this motion of the particle with a constant speed in the circular path is called as the uniform circular motion. Here the speed of particle is uniform, but you'll find that the motion of the particle, the direction of the motion of the particle is continuously changing. At each and every point of the particle you will find that the direction of motion is different, which is shown by means of these arrow marks. At the point A you will find that the direction of the motion is towards north, but when the same particle comes to the point B on the circular path, its direction is towards west, and when it comes to the point C, its direction is towards south, and when it reaches to point D, its direction is towards east. So here we can say that the speed of the particle is uniform, but the direction of motion of the particle changes at each point of circular path, and the continuous change in the direction of motion implies that the velocity is non-uniform, and thus the motion is said to be an accelerated motion. Because there is a continuous change in the direction of the motion, so we can say that the velocity of the body is not constant, it is variable, and because of this variable velocity we can say that the body is showing an accelerated motion. So remember, at any instant the direction of motion is along the tangent drawn at that point of circular path, and secondly, the velocity of the particle in circular motion is variable, or the circular motion is said to be an accelerated even though the speed of particle is found to be uniform. Now let us discuss the difference between the uniform circular motion and uniform linear motion. In case of uniform circular motion, as we have discussed just now, the velocity is variable, it is not constant, whereas in case of uniform linear motion, the speed and velocity both remains constant. So because the velocity is not constant, here it is variable, so the accelerated motion is shown by the body in the uniform circular motion, whereas in this case the speed and velocity both are constant, so the acceleration will be always considered to be 0. The acceleration will be 0. As you know, the acceleration is nothing but that is the rate of change of velocity of the body. So this is the two differences between the uniform circular motion and uniform linear motion. Now let us come to the another point, that is your centripetal force. What is centripetal force now? Now, since we know that a particle moving in a circular path continuously changes its direction, as we have just now discussed, whenever the particle moves, the continuous change in the direction of motion will be taking place, and as I have shown again here in this figure, and thus the motion in the circular path is possible only under the influence of a force which is termed as a centripetal force. So how this motion is possible in the circular path? Some force must be working to make the particle to move in the circular path, and that force under which the motion is found to be taking place in the particle is called as the centripetal force. So at each point of the circular path, this force is directed towards the center of the circle, as it is shown in the figure. So whenever the body moves in a circular path, a force which acts to make the body move in the circular path is always acting towards the center of the circular path, and this force actually makes the body to change the direction of the motion, because without this force the body cannot change its direction of motion in the circular path, and this force direction you will find that is always towards the center of the circular path. So now we can define this centripetal force, and the centripetal force is now defined as the force acting on a body moving in a circular path in a direction towards the center of the circular path. Now here also we have to remember this, that the direction of the acceleration is also changes at each point of the circular path. Why the direction of the acceleration also changes is only because there is a change in the direction of the motion, and along with the change in direction of the motion there is a continuous change in the velocity, means the velocity is variable, it is not constant. So we can say that the direction of acceleration also changes at each point of the circular path, but its magnitude always remains the same. The magnitude of the acceleration is not going to change, but the direction of the acceleration is continuously being changed because of the change in direction of the motion. So now we can say that the acceleration of the body is also variable when it moves in the circular path with constant speed. Next, come to some examples based on the centripetal force. The first example is that the gravitational force of attraction on the planet by the sun provides the necessary centripetal force to the planet to move around the sun in circular path. As we know, the planets always move around the sun in the circular path. So actually, from where they get the force? Some force is always required to make the planets to move around the sun, and that force is provided by the gravitational force of attraction of the sun to the planets. Then again, take another example. When a stone tied at the end of a string is reeled in a circular path, holding its other end in hand, the tension in the string provides the centripetal force. If you take a stone, tie it with a string, and just hold the free end of the string and start rotating the stone, which is tied with the string, and you will find that the tension will be created in the string, and that tension actually provides the centripetal force to make the stone move around in a circular path. Then, so remember, if this force means the tension created in the string will not be there, then the stone will not turn in the circular path. It cannot turn to move in the circular path. It is not possible. It is only the tension created in the string which provides the centripetal force to the stone to move around in a circular path. Take one more example. Suppose the gravitational force of attraction on the moon by the earth provides the required centripetal force to the moon to move around the earth in a circular path. So these three examples should be kept in the mind, because sometimes the question is asked in the examination. So mostly this, out of these three, one or two questions may be asked in the examination. Now let us come to the point centrifugal force. The centrifugal force is nothing but it is the force which acts in the direction opposite to the direction of the centripetal force. But we should not take it as a reaction force, because the centripetal force and the centrifugal force do not act on the same body. Centrifugal force is not the force of reaction of the centripetal force, because action and reaction do not act on the same body. So finally we can define this centrifugal force as a force assumed to be acting on the body in a direction away from the center of the circular path, and so it is called as the centrifugal force. It is just opposite to the centripetal force, because we have just now discussed that the centripetal force actually acts towards the center. So at the same time, the centrifugal force will be acting away from the center of the circular path. And remember, the magnitude of the centrifugal force is same as that of the centripetal force. Both will be the same and will be acting in the opposite direction. But remember that centrifugal force is not the force of reaction of the centripetal force, because action and reaction do not act on the same body. Now let us discuss the difference between the centripetal force and the centrifugal force. And the difference is very simple. At least these two differences you must keep it in mind, because sometimes it will be asked in the examination to differentiate this centripetal force and centrifugal force. So the first difference, what the definition we have discussed, that you can write that the centripetal force is the force acting on a body moving in a circular path in a direction towards the center of the circular path, whereas the centrifugal force is nothing but that is a force assumed to be acting on a body in a direction away from the center of the circular path is called the centrifugal force. Now this centripetal force is a real force, remember, and the centrifugal force is a virtual force. It is not a real force. So this is all about your uniform circular motion and about the centripetal force and centrifugal force. Now I have given some questions in the assignment. Please try to answer these questions in your school notebook. That first question is that explain the meaning of uniform circular motion and why is such motion said to be accelerated. Question number 2, draw a neat label diagram for a particle moving in a circular path with a constant speed. In your diagram, show the direction of velocity at any instant. Question number 3, is it possible to have an accelerated motion with a constant speed? Name such type of motion. Give an example of motion in which speed remains uniform but the velocity changes. Question number 5, a uniform circular motion is an accelerated motion. Explain it State whether the acceleration is uniform or variable. Name the force responsible to cause this acceleration. What is the direction of force at any instant? Draw a diagram in support of your answer. And lastly, question number 6 says that distinguish between the linear motion and circular motion. And number 2, the centripetal force and the centrifugal force. So these are the questions.